Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 7 of lesson number 10, Gravitation. So now in the last class, if you remember, we discussed more about the concept of gravitational. Like we are going in depth day by day as in sorry, as in when we are going like forward in the lesson, you are knowing some or the other thing extra about gravitation, right? So like we are left with we will be starting with today about the thrust and pressure, if you all remember. So thrust and pressure, like whenever it comes to force, because gravitation is a force itself, right? So, like we discussed on weight and mass, and I told you that weight and mass is one of the concept that is like eventually going to come up if you study about any kind of force, right? So, same way, this thrust and pressure, they are also correlated to like force. Whenever you're studying about force, what amount of pressure you're putting and like whatever thrust that we are applying, like everything is going to count there. So like we will be studying about thrust and pressure in detail today, but as you all know that before we start with the new part, we revise each and everything, right? So I want each one of you to start doing the revision like of the notes that you have taken in your book. You need to make sure that you all are taking all the valid points from the screen, and if you have not taken it, make sure you're doing it now, like while I show you all the screen. You can do it at that time as well, but make sure you do it. Okay. I hope every one of you have started doing the revision on whatever notes you have taken. Starting from part 1, if you all remember, part 1 was like the basic introduction to the whole lesson, gravitation, right? So I want each one of you to revise it properly. So I'm going to show you all the slides from the lesson that we have discussed on, and the first slide that we started for the lesson was the basic discussion on gravitation, what exactly it is and how exactly Newton got the idea of coming up with the concept of gravitation, because it also happened eventually. He was just sitting and thinking something else, and eventually what happened, like an apple fell on his head, and through which like he came up with the concept of gravitation, like why the apple doesn't go high up in the sky, why it always falls down. So that has led to like research work and all, because of which today we are aware of the term gravitation. Okay. So I want each one of you to please go through the slide. After this, we discussed on activity 10.1, which like makes us aware of the circular path that has been created with the stone, and not only a circular path, but like the stone was moving with a certain velocity that was of constant magnitude as well, right? Then we discussed on the most important part, that is universal law of gravitation. So I want each one of you to please go through the slide where we have the formula of the gravitational law which has been given. Then we discussed on like how can we derive the formula that you can see on slide, that is F is equal to capital G, that is gravitational constant, then product of their masses. So capital M is the like mass of product A, and small m is the mass of product B. So product of their masses upon distance squared. Okay. So this is what we discussed on, like how can we come up with the formula of F is equal to G capital M into small m divided by D square. Okay. After this, we discussed on like Sir Isaac Newton in detail, who exactly he was and what kind of like work he has done and why he is known, right? So everything has been given over here. I want each one of you to please go through this slide. I hope every one of you are reading it. Then we discussed on an example, like on the basis of the question that they have provided, that is all the given thing. mass of the earth, mass of the moon, the distance between them. We applied the formula and we have calculated the force, right? So I just want each one of you to please go through it. Then we discussed on the importance of universal law of gravitation. So I just want you all to please go through it as well. After this, we discussed on free fall through an activity. So I just want each one of you to please go through it. So here we have the explanation on free fall that has been given, and I want each one of you to please go through it as well. I hope every one of you are going through this slide. Then we came up with like how can we calculate the formula for acceleration due to gravity, that is small g. So that small g is equal to capital G, that is gravitational constant, mass m upon r is the distance square, or you can say the radius square. So g m r square. Okay. So sorry. After this, we discussed on how to calculate the value of g, that is acceleration due to gravity. I want each one of you to please go through it quickly as well, where we get the value of small g, that is acceleration due to gravity, as 9.8 meter per second square. Okay. Then after this, like after calculating the value of small g, we discussed on the motion of objects under the influence of gravitational force of the earth. So I just want you all to please go through this slide as well. I hope you all are going through the slide, because over here we have three different equations which have been given, and we have used that further as well, right? Then we discussed on this example 10.2. So I just want you all to please go through it. I hope you all are going through it properly. Then after this we had one more example. So I just want you all to please go through it as well. After this, we discussed on the concept of mass. So I just want you all to please go through it as well. Then we discussed on weight as well, right? So over here we have two different formulas, you can say, which have been given for force, and we are going to use the same for calculating the weight as well. Okay. Then over here we have like more information on weight that has been given. So I want each one of you to please go through it as well. Then we discussed on like weight of an object on the moon. So I just want you all to please go through it as well. Now this is very important and I hope like you have done it by yourself as well, because if you remember I told you to write this in your own write the formulas accordingly on in your book. Okay, then only you will understand it, like how the values are been put and how exactly we come up with the formula for this. Okay. I hope every one of you are going through it, because You need to know the table as well, where we have the mass of the earth and the radius of the earth and the moon given. Okay. Then we discussed on two different examples for calculating the same, right? So I just want you all to please go through it as well. So now we are going to start discussing about thrust and pressure. See, have you ever wondered why a camel can run in a desert easily? And like while you do it, so it becomes very difficult for you to do that, right? So why an army tank weighing more than 1,000 tons rests upon a continuous chain? And why a truck or a motor bus has much wider tires? Why cutting tools have sharp edges? What do you think? What can be the reason for all the questions that they have asked? So somewhere, like as you already are aware of the topic, that is thrust and pressure, you know that the answer lies in that itself, right? So in order to address these questions and understand the phenomena involved, it helps to introduce the concepts of the net force in a particular direction, that is thrust, and force per unit area, that is pressure acting on the object connected. So when it comes to thrust, it's net force in a particular direction. So whatever net force has been applied in a particular direction, that is the thrust, and force per unit area is the pressure that acts on the object concerned. Now the object can be anything. Now if you can see in figure 10.3, what that boy is doing, that boy is fixing a poster. Drawing pins are being pressed with the thumb perpendicular to the board. You have to look at the like thumb. What kind of, you can say, pressure he is applying to the nail or to the pin so that it fits the board, right? So let us try and understand the meaning of thrust and pressure by considering the following situations. So we have two different situations over here. The first situation is, you wish to fix a poster on a bulletin board as shown in 10.3. So we have this figure 10.3, and what are we doing is we are trying to fix that poster with a poster with a pen on a bulletin board. Now to do this task, you will have to press the drawing pins with your thumb the same way as it has been shown in the picture, right? So you apply a force on the surface area of the head of the pen. So you have the pen, and what do? You apply force on the surface area of that pen, right? So this force is directed perpendicular to the surface area of the board. Where is this force directed? It's always going to be perpendicular to the surface area of the board, and this force acts on a smaller area at the tip of the pen. Where does it acts on? It acts on the smaller area at the tip of the pen. Okay, so this was the first situation. Now the other situation that we have is, you stand on a loose sand, your feet go deep into the sand. Okay, like just imagine yourself standing on the sand, and if you stand it over there like on that sand for few seconds, you will feel like you're going deep into the sand, right? After this, like after standing on the sand, lie down on the sand, and you will find that your body will not go that deep in the sand as compared to the one when you were standing. So in both the cases, what is happening? The force exerted on the sand is the weight of your body. So whatever force that you are exerting on the sand is the weight of your body, right? So you have learned that weight is the force acting vertically downward. Where does the where do the weight acts on? It acts vertically downward, right? When you stand or like when you lie down, your weight is going to be perpendicular to the surface, right? So see, the force acting on an object perpendicular to the surface is called thrust. What do we call it as? We call it as thrust. Okay. So, when you stand on loose sand, the force, that is the weight of your body, is acting on an area which is equal to the area of your feet. Where does it act on? It acts on the area that is equal to our feet, right? So, thus, the effect of force of same magnitude on different areas are going to be different. So wherever the force is going to act on, it's going to be with the same magnitude, but it is going to act on different areas, and that is the magnitude is going to be different over here, and the effect of the force will be different as well, right? So in the above cases, the thrust remains the same, but the effects are different. So thrust is same, but the effect on that are different. Okay, so therefore the effect of thrust depends on the area on which it acts. What does it depends on? It depends upon the it depends upon the area on which it acts. So the effect of thrust on sand is larger while standing than while lying. So whenever we stand, the effect of thrust will be larger as compared to the position when we lie down. So thrust on unit area is called pressure. What do we call it as? We call that as pressure, and thus pressure is equal to thrust upon area. What does like thrust stands for? Pressure, like it's equal to pressure upon, like pressure is equal to thrust upon area. So substituting the SI unit of thrust and area in equation 10.20 that we have, we get the SI unit of pressure as Newton per meter square. Okay, what is the SI unit of pressure? Or you can say SI unit of pressure is Newton per meter square. Okay, so in honor of scientist Blaise Pascal, the SI unit the SI unit of pressure is called Pascal, denoted as PA. So we have a numerical that we are going to discuss on now. But before that, I want you all to write about thrust and pressure in your book, as you should be having a proper note on it. So please write it down in your book, everyone. Like, I'll be moving on to the next slide. You have to even write the SI unit. Each and everything that you feel is important needs to be noted down. Okay? You can even take some points from here, because here we have the most important points on like the effect of force and all that has been given, right? I hope every one of you are taking a note of. You can even write the formula and SI unit from here, which is again very important as I said, because you can get them in exam as objectives. Now the next thing that we have is an example to discuss. So see, a block of wood is kept on a tabletop. The mass of the wooden block is 5 kg and its dimensions are 40 centimeter into 20 into 10. So find the pressure exerted by the wooden block on the tabletop if it is made to lie on the tabletop with its sides of dimension 20 centimeter, 10 centimeter and 40 centimeter into 20. Okay. Now the mass of wooden block that they have given is 5 kg and the dimensions given are 40 into 20 into 10 centimeter, right? So here's the weight of the wooden block apply, like the weight of the wooden block is going to apply a thrust on the tabletop. Now you know what is thrust, right? Thrust is equal to F and we know that F is equal to m into g, that is mass into acceleration due to gravity. So mass given is 5 kg into 9.8 is the fixed value, right? So we get the value for thrust as 49 Newton. Now we need to calculate the length and breadth, right? So for that, like we will be using the formula as area of a side is equal to length into breadth. Now the length of the block is 20 and the breadth is 10. So when we calculate this, we get the answer as 0.02 meters square. Now we need to calculate the pressure, right? So we know that pressure is equal to thrust upon area, right? So thrust is 49 Newton and area is 0.02 meters square. Now I hope you understood why we calculated the area of the side and why we calculated the thrust, because we need to calculate pressure, right? So for calculating pressure we need to have like the area and the pressure and the thrust, right? So that is the reason we have calculated both of them before, and we get the pressure as 2450 Newton per meter square. Okay, so when the block lies on its side of dimension 40 centimeter into 20 centimeter, it's going to exert the same thrust. So over here again we are going to calculate, like thrust is going to remain the same, but the length and breadth changes, right? So it will be 40 into 20 now, and we'll get the answer as 0.08 meter square. So again we will calculate the pressure as thrust upon area. So pressure like thrust remains the same, but area changes to 0.08. So we get the answer as 612.5 Newton meter square. Okay, and it's the same thing that they have explained. So I just want you all to please go through it, because this kind of numericals can be asked for your exam as well. So make sure you know them. Okay, you can even write this in your book and keep, so that you can revise it whenever needed. So I hope every one of you have understood and you have like taken note of it as well. Now in the next class we are going to start with pressure and fluids. So I'm not going to start with this today. I'm going to start with this pressure and fluids in the next part. Then we even have buoyancy to discuss. We'll be discussing on that. Then after buoyancy we have like activity 10.4 that we will be discussing on. Then we have like why objects float or sink when placed on the surface of water. Okay, then we will be discussing on this activity 10.6 again. Then we have Archimedes principle to discuss, which we will be discussing again. Okay, then after Archimedes principle we have the next thing as relative density to discuss. So we'll be discussing on that as well, about relative density. Then we have the summary discussion for the whole lesson, and if you remember, in this we have like 22 questions which have been given, right, which we will be discussing at the end of the lesson. So I'm going to show you the questions again. Please go through each and every question that I'm showing you on screen. So this is the last question that we will be discussing up for the whole lesson, gravitation. Okay, make sure whatever we discussed today with respect to thrust and pressure, every one of you are revising it. Okay, and whatever type of questions that you came across through all like the 22 questions which you were able to answer, make sure like you are revising them as well, because you know what kind of questions are there at the end, right? So I'll end this part over here, but make sure you do your revision part as well. Okay, so I'll end this part of gravitation and I'll be continuing with the rest of the part like that has been left in the next class. Thank you everyone.